Okay, so the first problem on our Unit 8 test review asks what the coefficient for potassium is in the balanced equation, which means we need to balance this. Now, you can write each element underneath. So we have a sodium, we have potassium, and we have sulfur. Do not bring the subscripts down underneath when you do this. All right, so if we look, there's no subscript here, which means we have 1 sodium on our reactant side, and then we have a subscript of 2 on the product side, which means that we have 1 sodium and 2 sodiums. We have a subscript of 2 on the potassium and no subscript here, which means we have 1. So 2, 1. And both of our sulfurs have no subscripts, which means that we have 1 on both sides. Alright, so now we need to balance. If we look, our sodiums, we have too many on our product side. We don't have enough on our reactant side. So we need to multiply our reactant side to get to 2. So we're going to multiply it by 2. Whatever you multiply by becomes your coefficient. So since we multiplied by 2, we put that up here as well. Remember, coefficient is the big number in front. And we also need to multiply our potassium on our product side by 2. So again, whatever number we multiply here has to come up and be our coefficient. So that means the 2 goes in front of the potassium. Alright, well, now if we reassess, we have 2 sodiums on the reactant side and 2 on the product, 2 potassiums on the reactant side and 2 on the product, and we have 1 sulfur on each side, which means that we're done balancing. There's no number in front of the K2S, which is potassium sulfide, or the Na2S, which is sodium sulfide. When you have no number in front, that means that the coefficient is 1. So you can either put numbers in front or you can leave them blank. You just have to understand that that means 1. So to answer the original question up here, it says, what's the coefficient for potassium? The answer is that K has a coefficient of 2. And the reason why it's 2 is because we look up here, here's potassium all by itself. Our number in front is 2. That's our coefficient. Okay, number 2. In the reaction, N2 plus 3H2 yields 2NH3. What is the mole ratio of hydrogen to nitrogen? Okay, so first thing you need to know is you need to know that N2 is nitrogen and that H2 is hydrogen. And if you want to remember NH3 is ammonia, you can. This asks us for the mole ratio of hydrogen to nitrogen, which means that we're only worried about these 2 substances here, nitrogen and hydrogen. Mole ratio means coefficients. So what we're really concerned about, as far as this goes, is our numbers in front. Okay, so this is actually very easy. Remember, coefficients give us mole ratios. So there's no number in front of the nitrogen, which means that it has a coefficient of 1. So if you need to, you can put a 1 in there. And there's a 3 in front of the hydrogen. So that means that our mole-to-mole ratio is that there's 3 moles of hydrogen to every, there's supposed to be a colon, to every 1 mole of nitrogen. The other way you can write this is just 3, 2, 1. All right, in number 3, same type of problem as number 2. We're given a reaction for the formation of water. We've got hydrogen reacting with oxygen to make water, and our coefficients here are 2 for hydrogen. We have nothing in front of oxygen, so that's a 1, and then 2 for the water. And it asks us for the mole ratio of hydrogen to water. So again, remember that the coefficients give us our mole ratios, which means that 2 moles of hydrogen are equal to 2 moles of water, because that's our coefficients on both. They both have a 2 in front. Or the quicker way to write this is 2 to 2.